Okay. So my name is Vishwanath. I'm an architect at MOSIP. Been associated with MOSIP for the last 2 years. So today's talk is about the login feature that is provided by MOSIP system. Move to the next slide. I'll give a very brief introduction about MOSIP. MOSIP is a modular open source foundational identity platform. We are basically one of the DPGs, digital public good. We use open APIs and standard. Basically, we want to avoid a lot of vendor lock-ins when we take a system like a foundational system. So it runs for few centuries sometimes, right? Typically 50, 100 plus years. So we want to avoid the vendor lock-in problems, right? So we use a lot of open APIs, and wherever possible, we use a lot of standard APIs so that there could be multiple vendors getting compliant to these standards, and they can integrate to our system. We are actually an open source system, Mozilla Public License 2.2. We are fully open source, and we also take a platform-based approach. We are not a very large monolithic system. We can the modules of MOSIP can also be integrated with an existing foundational ID system. Like this talk is about a login feature, right? Which we call it as IDP, identity provider module, which could also fit into an existing foundational ID system. It can be integrated. So we take a platform approach. Security and privacy. Coming to this becomes paramount in our designs. Because we are talking about a foundational ID where you will have ID for residents of the entire country, right? So we deal with large volume of data, and it's also very sensitive data. So security becomes a paramount for us, and privacy is also very seriously taken care. The reason again being it is of residents, right? And we don't want people to misuse our system for doing profiling, etc. So we take privacy also very seriously in the MOSIP designs. So this is about MOSIP. As a platform, we provide majorly three different functionalities for the countries. So countries basically take our open source code customized to their need and then create their foundational identity system for the countries. The three things are ID issuance. Typically, this module deals with residents coming and registering themselves, giving their biometric, giving their demographic information, some identity proofs, etc. And then it goes through a lot of deduplication work in the backend. And then we finally give a digital identity or also a printed card. So this is again customizable by the country to pick and choose what they need. So then we have this identity verification. Identity verification is what this presentation is about. So I'll cover that in the next slide. So the last one is about the ID lifecycle management. When we say ID lifecycle management, it is about residents changing their address, changing their mobile number, changing their names, right? So for all these cases, there should be a very easy medium for a resident to go and apply for these changes to their foundational ID. So we provide modules which deals with this as well. And so majority what we take care is interoperability and vendor lock-in situation using the open API standards. One extra small information, MOSIP, as of today, easily 50 million plus identities has been so far issued using this platform in a couple of countries together. Moving to the next slide. So coming to the basics, what is an identity verification? So identity verification basically is a process where an individual resident goes to a service provider and wants to prove his identity to get any kind of private or government service. One example is a resident goes to a teleco provider and he wants to confirm his identity and get a new telephone number. So these kind of use cases majorly wants to deal with the ID verification. So coming to the MOSIP system, we support two types of ID verification. One is called yes or no verification. So this keeping privacy in mind. So somebody can provide an ID number and ask what is the age of a particular person, saying that age is particular. For example, he is 19, 20. And then the system just going to verifies and says yes or no by verifying their biometric also together. So a person gives his biometric ID number, the unique ID number that is issued to him, and his age. And that can verify, he can make an API call and the verification say yes or no. So the other type of verification is KYC. So this is needed for countries' legal requirements where before they provide service, they want to have a verified information of their customers. So this is know your customer. So this kind of ID verification is where a user goes to a service provider gets his ID and his biometric, which is again encrypted. It goes into a secure fashion, reaches our server, and we provide his verified information that is available in the foundational ID system in a signed mechanism for a relying party to actually verify that information and then keep it for the legal needs. Coming to models, with our experience with the countries so far, we have seen various scenarios where these verifications are required. So based on these scenarios, we have 3 models of ID verification in the MOSIP system. The first one is called direct API based. So direct API based is typically for scenarios of a very controlled environments like bank, and it has a very good connectivity to the servers. So it's fully online. People goes in person, and then they provide the same example that I told. They want to transfer some money and do some kind of address updates to the account, etc. They provide their ID number again and provide their biometric. And the banks will be able to make a KYC request, and they will be able to get the verified signed information, which can they trust and provide the service. So the other module is VC-based local sharing. VC stands for verifiable credentials. So this takes care of use cases like individual goes door to door and wants to provide some kind of benefit to the residents. Okay. So where the connectivity is very limited, you can not always say, you can also think about an island. So there is some kind of benefit that needs to be transferred. They go to an island where there is not much of connectivity. So there, our system currently has this verifiable credential concept, which can be downloaded from our server. The user in his mobile phone, user can actually register and download this verifiable credential, which has his photograph and which has his demographic details, which can be shared over a Bluetooth to the person who's trying to verify the resident. And he can use a local face authentication or verification system by using the photo that is available in the credential, and he can verify the person. He can do a manual verification or some kind of ML based local verification to verify that his ID and this is the person, and he can actually provide the benefits. This is we have. And the third one is about OpenID Connect based. So this caters to the needs of online self-service and assisted modes. So today's topic is about OpenID Connect based integrations or model that is newly getting introduced in MOSIP platform. When it comes to the OpenID Connect as a protocol, we have taken some specific approach about how we integrate it with the MOSIP platform. So one approach is about thin layer around an existing verification module. Basically, our ID verification module drives around a lot of policies. We don't want to disturb those policies much, and we want this OpenID Connect feature to be added as a very scalable scalable system to be added to the existing verification module. At the same time, we don't even need to look at the data and manage the resident data in this OpenID Connect module or the IDP module. So we have taken this thin layer approach. We also support only authorization code flow. So this is more from the security perspective. When it comes to the OpenID Connect, there are other modules, other ways of integrations also, which is called implicit module, and there is a hybrid module. We don't use those flows. We support only the authorization code flow for the security concerns. And the final integration is also something we have taken as a dynamic library dependency. The whole idea about here, as I mentioned, in the platform-based approach, right? So we take this integration to the actual verification system as a library which gets downloaded when our container starts. So this way, any country wants to use our IDP system, they can write a simple implementation for a very well-defined interface that we have given, and do all the interactions in a library, which can be built as a jar file and can be provided by using the Docker, which is actually released by MOSIP, right? So so country doesn't need to actually customize this library at all. They can use the MOSIP released Docker containers and just provide the library-based implementation. This is a step towards making the integration simpler rather than building everything. So this is the approach we have taken when we want to use OpenID Connect with MOSIP platform modules. So there are various advantages we saw when we are using an OpenID Connect based module. So basically, we avoid the custom code building for integration. I also told about the direct API based integration. So there, so a relying party who wants to authenticate the user, right, has to integrate with our backend systems to provide the ID and demographic biometric details. Also, they need to integrate with our biometric devices using another interface called Secure Biometric Interface, SBI interface. So we are trying to avoid when we are using an OpenID Connect based model, we are avoiding those kind of integration problems. We are reducing the custom code building part. It is also a very quicker integration because it's a very standard protocol. There are a lot of libraries available for various languages. So the integration becomes very quick. There is also seamless inclusion of authentication mechanisms. So the idea is today we provide biometric and OTP and PIN-based authentication mechanisms. Later, we want to support hardware tokens. We want to support wallet-based authentications, wallet application-based authentications. So this way, there is no integration changes required in the relying party for us to provide these additional authentication mechanisms to the residents. So it becomes very seamless, very little friction. We also this also avoids unwanted profiling in the sense. So when we are using the OpenID Connect, even the ID, right? ID of the user, the unique identification of the user, foundational ID of the user is going to be entered directly on our service, not on the relying party apps. So even that information will not be available for the relying party. So even if there are a relying party wants to collude, they will not be able to profile because what they get from a MOSIP system on a successful authentication is a token. So this token is unique per relying party and they don't have the ID itself. So this becomes a little easy for us to handle profiling kind of a problems. And it also collects a very explicit user consent. We explicitly ask user that these are the details that we are going to share. I'll show a small demo. We can look at how we are collecting these details. And we also want to support various assurance levels, like somebody wants just an OTP based authentication is good enough. For example, somebody wants to register to a benefit kind of an application, or they want to go to a provident fund kind of a government portal, right? They can just need an OTP kind of authentication. But some high value transactions in bank might require definitely a biometric based authentication for them to provide that service or do that particular functionality. So when relying party is integrating using OpenID Connect, they also can use the assurance levels that is supported by the platform, supported by this module, for them to perform various levels of authentications. So we'll go to a very short demo. Sorry. Okay. Um, so I hope my screen is visible, not the presentation, the website that I'm hosting in the Chrome browser.
We can see the health portal, yes.
Okay. So what we have here is a health portal. We are basically for the demo purposes mocking a relying party. In this demo, our relying party is actually the health portal who wants to authenticate the end user online, right? Online in a remote location, right? He wants to authenticate, and how can he use the foundational ID itself for providing a login feature? So he can provide his username, password, typically how he does. He also now gets an option. Once the relying party integrates with the foundational ID, he also gets an option to use his foundational ID to log in. So he clicks here. So you can see that the site redirected to IDP. So we were actually here, the health services. Okay, it's a different domain name. So on click of this, it gets redirected to our IDP system, the OpenID Connect based interface of MOSIP platform, where he is going to enter his ID, and he will be providing his demographics. Okay. So I have some technical, just give me a minute. I'll just try for a minute. Otherwise, we can carry on.
No problem. Don't worry, Vishwanath. Take your time.
Okay. I'm not able to make the biometric devices detected, but I'll show you a different mechanism of login. So we have this more ways to sign in based on the assurance level. We can also log in using a PIN. So user provides his ID number, and he can also provide his PIN. So in the same way, we also have an integration with a biometric device, which interacts using a standard mechanism called SBI, Secure Biometric Interface. It's not a very universal standard, but we have a very well-defined specification, and we also have vendors compliant to the solution. So we can use such biometric devices if it is already installed and configured. We will be able to select a device and provide our biometrics after giving the ID. But here I'm using the PIN and I'm logging in. Okay, so once login is done, user will be able to see a consent screen, a typical flow of what you see with login with Google or login with Facebook. They get an icon of the relying party who wants to get your information, and what are all the various user attributes that he's looking for. We also have this OpenID Connect basically provides a functionality to give what are all the essential claims. So the relying party can tell an IDP system that what are all the essential claims that he need for providing a particular service, logging into this particular application. He can also provide voluntary claims of extra information that is more of an optional need that user can choose to provide or not. Here I'm selecting for birth date and gender, and then I'm going to tell allow. Basically, I'm giving my consent to the IDP system of the foundational system, saying that you are okay to share these details of mine with this relying party. So that is what we are agreeing. The end user is agreeing to the system. On allowing, we will be able to see that the health service, we are again redirected back to the health service mock application that we have. You will be able to see that it's able to read the name. It is able to get the email information from the IDP system, and gender information and birth date. Since phone number was not consented, we can see that phone number information is not received. Right. So this is a very short demo on the OpenID Connect integration that we have today. We are improving and adding more features to this. Any questions on this demo?
Have you anything else to present? Because we'll take questions all together on the presentation. I know at least John's put a question.
Okay. Okay. I'll go back to my presentation. Okay, so I have a very small flow diagram. So this is going to clarify in the background how this actually happened, right? What we saw in the demo, just to give a background of how we were able to do it in the background, right? So in this flow, it's a very simple flow. I'll run through this very quickly. We have this relying party UI application, and we have a relying party backend, which is our health services that we saw in the demo. The IDP is our module, OpenID compliant module that has a UI and backend system. And also we have this verification system library that I spoke about that gets downloaded dynamically once the container starts. So this is where a country wants to use this particular module in an existing foundational system, can integrate all their code into a particular library and feed in as a very runtime dependency for us. So interactions between this will define the flow. So user wants to actually log in. He clicks on the login using MOSIP button. And then we see there is an authorized redirect that goes to the IDP. So this is a very standard OpenID compliant, which I have mentioned in green here. So we do some kind of validations to see based on when this particular relying party was registered to the foundational system. What are all the authentication mechanisms that he can use? What are all the user attributes he's allowed to ask? So those kind of informations are configured. We are going to validate that in our database. And then we are going to show the authentication page. User is going to provide this we saw. And then he's going to provide, select the biometric device. So if there are multiple devices connected, he's going to select one of the device and he's going to click on scan. And then what the UI application does is integrate with this SPI. As I told, there's a secure biometric interface that is defined, a well-defined protocol to integrate with MOSIP compliant biometric devices to get a signed and encrypted biometric, which can be only decrypted by the server. Kind of a encrypted blob is what we are going to get in return. And then we are going to send this biometric information and ID to the backend, which is the IDP's backend, which is going to call a particular well-defined method on the library, a dynamic library. And it is expected that this library will be able to actually speak to the verification system, the country's foundational verification system. And then it's going to return back something called KYC token. This is basically a token that we want to exchange later. And a PSU token, we call this partner specific user token. So this is a unique ID that we want to give back to the relying party, which is different for each relying party. So these two information is what we are expecting from the verification system to give back to our module. We are going to store this KYC token, and we are going to also check whether existing consent is available. For example, user logs into the same site, consent is already given, right? Whether we want to use that same consent. So we will check that. If consent is already given, we will go to the next step. Otherwise, we collect the consent. And we're going to generate something called authorization code that gets sent to the relying party. Relying party is going to send it to the backend. So this is OpenID compliant thing. And then there are going to be two APIs, OpenID compliant APIs for token and user info. It is going to be called by the relying party using their standard libraries. And they make a call and we exchange the KYC token for the actual KYC information with the server. and then we are going to store the KYC encrypted data, which we are actually going to means we are going to give ID token and access token. These are two different tokens as per the OpenID spec that will be actually passed on to the relying party as a response to the token API. Then there is an user info endpoint, which is where we are going to give the encrypted KYC information. So this is encrypted in such a way that not even the IDP system can look into the data. It's going to be encrypted and it's going to be given to the relying party. Relying party backend application is going to actually decrypt, verify the signature also. It's going to be a signed information and it's going to consume the data. Okay. Since we are running short of time, I'll just move on. There are some interesting challenges that we faced when we were actually building this IDP module. So when we want to integrate to our existing verification module, as I told, it runs through a lot of policy constructs. So making sure that it is encrypted enough, we follow the same policies, and we derive OpenID based things from our own policy was very interesting challenge. We also integrated with the SBI from a JS application, from a JavaScript UI based application. We had a lot of scenarios like how do we discover, how do we handle multiple device scenarios. There were some challenges around that. And also from the OpenID compliant, that was also very interesting. There were very minor compliance issues. Debugging that was very good. Was very interesting. For example, there was an ID token has to have issuer value exactly matching the URL. That was not very clearly there in the spec, finding that out. And then client ID is an optional thing in a very particular case that has to be gone to, again, not an OpenID Connect documentation, but we have to go to the OAuth documentation to find out. Those kind of interesting challenges we have seen. Moving on, there are a few interesting things that we are building currently. One is mobile app wallet-based authentication. We want to show in a QR code. We want end user to scan it and use that for authenticating, doing a local phase authentication, and then maybe releasing a token, and we want to authenticate user. We want to support multi-factor authentication. Currently, multi-factor authentication is not there. OTP plus biometric, those kind of authentication. We want to support hardware tokens and software tokens that is available in the market today. We want to add support for that. We want to also give a personalizing capability to the residents themselves to say for various assurance levels, what kind of authentication factors. For example, if somebody wants to make sure that is mobile wallet-based authentication should be always used. That is something we want the end user to do. So that is something we are working next. Yeah, that brings to the end of the presentation. I can take questions.
Excellent. Thank you so much.